Okay, 8.4, we're going to start looking at different ways to evaluate logarithms. And to do that, we need to understand the laws of logarithms. So these are not all of them, but this is an introduction into a few of the laws that we're going to be looking at when you're combining or simplifying equations dealing with logarithms. The first one is the product law. In the product law, the log of xy or x times y, if there's a multiplication in the argument, that's the same thing as doing log of x plus log of y, assuming all three of them have the same base as a. So when you're multiplying the arguments, when there's an argument that consists of multiplication, that can be broken down into the sum of the separated argument values. So log of xy is equal to log of x plus log of y. In the same way, then you have the quotient law. Log of x divided by y gets split into log of x minus log of y. In here, you have to remember the order is going to be important. It is the numerator minus the denominator. You will not do y minus x. That would give you a negative answer, or give you an incomplete answer. So log of x minus log of y. Once again, the bases have to be the same in all three, and all you would do is subtract the numerator, the denominator from the numerator. Finally, the power law. In the power law, what it says is that if there's an exponent on the argument, so x is the argument, it has it to the power of 4, that exponent can actually be brought down and become the coefficient. So for example, if I saw 3 log x, this is the same thing as log x to the power of 3, because that 3 can go up and the 3 could actually come down. So both ways it works. Okay, let's apply some of these to a few examples out of the textbook. Okay, let's start with our first example. We have log with base 5, log 6 plus log 4.5. This is a direct use of the product law, which we're going to split. This is split up. We're going to combine this into log base 5 of 6 times 4.5. Right? So 6 multiplied by 4.5 is going to equal 6 times 4 will be 24, and half of that is 3. So log base 5 of 27. Oh, I'm sorry, this is supposed to be a 3. So log base 3 of 27, and then 3 to the power of what number will give me 27? I already know the answer to that is 3. So your solution is straightforward. Log base 2 of 48 minus log base 2 of 3. This is the quotient law, where if you have two different logs with the same base being subtracted, it's the same thing as dividing the arguments. This becomes log base 2 of 48 divided by 3. In this case, it's going to be log base 2, 48 divided by 3 is 16. 2 to the power of what number will give me 16? The answer there is 4. Okay, very straightforward in terms of how you apply it. Let's find one more example to do, just so we get a good mix of questions in here. So example number 5 in your textbook, what it says to do is to graph these two functions, f at x and g at x, and compare them. We're going to do the same. We're going to achieve the same process, achieve the same purpose, but algebraically. So g at x is the log function, just shift it up by 3. F at x is the log function with a horizontal stretch of 1,000. Well, this I can split up because I just learned the product law, which is that if there's two things being multiplied in the argument, they can be split up and added. So this would be log of 1,000 plus log x. Now, if there is no number given for the base, by default, it's going to be treated as 10 because that's what it is. So 10 to the power of what number will give me 1,000? That is 3. So f at x and g at x are actually the same function if you apply the laws of logarithm, the product law, in order to split 1000x and then simplify it down from there.